Hi, and welcome back to the Aftermarket Arcade. Today we're going to be taking this Fluke 6800 interface pod for the Fluke 9010A, or in my case, a 9005A, and we're going to turn it into a 6502 interface pod. So the first thing I need to do is hook the cable into itself here and run an auto test, and we see that passes. So the next step is to go ahead and disassemble this pod. We've got the case off now, so the next thing is to just remove some of the peripherals here. The cable's disconnected. Alright, flip it over and get the boards separated here. Okay. So this comes apart real gently, just like that. This is the interface PC board, and this is, I believe, the logic PC board. So the next thing we'll do is go ahead and get our ROM chips off of here, or ROM chip off of here. And we do that by just very gently prying at this edge. Come on, little guy. There we go. And we'll pull the processor out the same way. There we go. Came right out. And the next thing we're going to do is go ahead and pull this U12 chip out, because once we convert it, this will no longer be part of the logic, and we will be able to use some of its pinholes to jumper wires. So I'm going to go ahead and get the desoldering gun out and take this chip out. Now we make it to the fun part. I've got these schematics linked in the description. I've got my work mounted in the pan of ice. I've got an X-Acto knife, Sharpie, wire strippers, some wire wrap wire. Now the first step is to cut pin 12 on U10, I believe. And I've got that marked right, let's see if I can find it on camera, right here. So we're going to make a cut right there, and then we're going to jumper this wire over to, I believe this is pin 39. Yeah, this is pin 39 on the processor. So we've done that. Here's what it looks like. You always want to test continuity on the old trace and the new trace to make sure the old trace is cut and the new trace is working. All right, step 2 is to cut this trace right here. And this one right over here, and then run jumper wires from these locations over here to U13 at 5 and 6, and then jumper pin 4 to pin 7 to ground pin 4. Step number 3 is to cut this trace here where U11 comes up on top of the board. So we've cut that trace. And then jumper this trace from here to here. This is U9 pin 4 to pin 14. That effectively brings that up to 5 volts. Alright, step 4 is to pull R7 up here. We got that out. And there's not a really good way to float pin 39 here. So what I did, I don't know if you can see that, but I put pieces of electrical tape, or super glued a small amount of electrical tape to either side of the contact there. Super glue doesn't stick specifically well to flat, smooth metal, so it'll be easy to get off later if we want to convert this back. But that ought to float our pin. Let's go ahead and get this put back together. All right, now that we've got this ZIF socket back together and we have pulled out R7 here, it's time to cut the trace between U6 and U13 and then reconnect U13's pin over here to U10 pin 9, which is 7, 8, 9. So here's what that looks like. We've got a cut right there between U6 and U13, and flip it over. We got a jump from U13, where is that, right here, all the way over to U9. Or actually that's U10 pin 9, and this is U13 pin 10. All right, step number 6 is to connect pin 38 of U2 to pin 45 on this pin header. And the pin out is not like you think. Let's flip it over. It goes 1 through 30, and then starts at 31 and goes all the way to 60. That makes perfect sense until we get to the pin header on the interface board, and then it doesn't make sense anymore. But I'll show you that when we get there. Right, step number 7 looks like this. You cut U6 at pin 3, and flip the board over, and you jump pin 1 over here to pin 7, 8, 9, 10 on U11. All right, step 8 looks like this. You make a cut right here where the resistor is connected, and goes over here to looks like U8, and then you jump from U12's pin 2 over to U8's pin. Let's see, this is 8, 9, 10, 11. Then we take U12's pin 12 here and connect it to 13. Actually, no, that's pin 12 to 13 here. So we're going to make this jump here. This board's almost finished. We need a 6502A processor to put in here, and a ROM to put in U3. Now I have flashed that to a 2716 because I didn't have a 2516 just laying around, but it should work. And I got that ROM image from I think JamArcade.net, so we'll see if that works in this particular device or if we'll have to use a different ROM. All right, I went ahead and did the modifications to this board because they're pretty simple. You cut this trace right here. I don't know if you can see that, but I will put pictures in the forum post. And on the flip side, let's see, you want to jump, what is that, you want to jump U5, pin 1 to pin 20, and that supplies 5 volts to pin 1. And then you jump pin 45 to pin 5 over here on this connector. And like I said, the counting is a little different on these pin headers. This one starts here and goes 1, 2, 3, 4, 5. So this is the pin you want to connect to. And on this one, it's just like the one on top. It's 1 through 30 here. And let's get that in frame. And 1 through, or 31 through 60 here. So the 15th pin, counting from this bottom left-hand corner, is pin 45, which you're wanting to connect to here. So we've completed the modification. Let's go ahead and put it back together and see if she runs. So I was getting the timeout issue initially, and that was because the 6502 ROM has a dual ROM set in it, one for the 6800 and the other for the 6502. So I lifted this pin 19 and connected it to VCC, which enables the ROM to seek the 6502 program code and not the 6800. All right, moment of truth. Let's turn it on and see what we get. Got a power up okay. Got our ribbon cable plugged into the test socket here. We'll hit the automatic test there. Pod self-test 6502 OK. So that's how you convert a 6800 pod into a 6502. Thanks for watching, and hit subscribe if you'd like to see any more like this, and check us out at aftermarketarcade.com. Thanks for watching.